In this experiment, different ways of calculating final speed were investigated using a modified Atwood setup. Conservation of energy and kinematic equations were used to calculate the final speed. Experimental data revealed an average final velocity of 0.497 meters per second, while energy conservation predicted 0.565 meters per second. There were potential sources of error such as human reaction time and friction.
And now for some background. The law of conservation of energy says that energy can only be changed from one form to another, not increased or decreased. Writing this in equation form, we get initial potential energy plus initial kinetic energy equals final potential energy plus final kinetic energy plus non-conservative work. Non-conservative work accounts for the total change in kinetic and potential energy of the system that might result from a non-conservative force at work, such as friction. In this experiment, non-conservative forces were considered negligible, so we are not including it in our calculations. The final velocity of the cart was calculated using this equation, as well as kinematics equations, two of them pictured here. There are four of these equations in total, which assume constant acceleration and relate the four key variables of kinematics: acceleration, time, displacement, and velocity. Procedure. A modified Atwood machine was set up, as shown in this image. Mass 1 was on a wheeled cart on the lab table, while Mass 2 was hanging over the edge. A distance for Mass 1 to travel, h, was determined based on how far Mass 2 could fall before hitting the floor. This event would create an incorrect, non-accelerating system. When the machine was free to move, gravity pulled Mass 2 down, also putting Mass 1 across the table as the pulley redirected the force. The time it took for Mass 1 to cross distance h was measured, and this was repeated 6 times.
Okay, so as far as experimental data and data analysis goes, for the mass of the cart, we found it to be 923.3 grams. For the distance the cart/mass traveled, we found it to be 0.48 plus or minus 0.001 meters. And then we did 6 trials. All of these units are in seconds, and all uncertainties are 0.26 seconds, which is attributed to human reaction time and resolution. Okay, so for the first trial, we got 1.79. For the second trial, we got 2.00. For the third trial, we got 1.90. For the fourth trial, we got 2.00. For the fifth trial, we got 2.00. And for the sixth trial, we got 1.90. So the average time was 1.93 plus or minus 0.26 seconds. And the final speed we found to be 0.497 plus or minus 0.07 meters per second through the kinematics equations. And then the final speed through the conservation of energy equation was 0.565 with an uncertainty of 0.0006 meters per second.
Now to find our final velocity of the cart using our first method, kinematics equations. We will isolate the acceleration in this first equation and plug it into a different one. Now to plug in our isolated acceleration into our second kinematic equation so we can solve for our final velocity. Now we plug in our measured values of distance and time in order to solve for our velocity. Now, to determine the final velocity of the cart, using the second method, conservation of energy. Now, the law of conservation of energy states that our final kinetic and potential energies summed up equals our initial kinetic and potential energies summed up. Now, we only needed a couple of these elements in our situation because we have started with no kinetic energy, no spring energy, and our second mass's kinetic energy is the only one that matters because it's the only one that changes. So we can say M2G H1, that's our initial gravitational potential energy, equals our final gravitational potential energy, so M2GH2. Now, at the end, we'll also have kinetic energy in both the cart and the mass, too. But they will have the same velocity, so we can simplify immediately to say 1/2 v squared m2 plus m1. And we will have no non-conservative work because that is considered negligible here, and no spring energy. So now we can go ahead and solve for our final velocity. Now we are going to go ahead and plug in our data in order to solve. And now we just need to simplify. And that is our final velocity as calculated by method 2, conservation of energy.
It takes time for the stimulus of the cart hitting the end of its track to reach the human's hand, meaning the times recorded were likely slightly longer than they should have been. This was accounted for by adding human reaction time, 0.25 seconds, to the uncertainty on time measurements. But it does mean that all the likely final speed values predicted by the calculations for the first method are smaller than they should be. Second and third sources of error would be air resistance and friction, which were both assumed to be negligible in this experiment. Both forces push back on the cart, causing it to accelerate more slowly. These are forces only significant for the second method of calculation, conservation of energy. The non-conservative work done by air and friction was not included in the calculation because their magnitudes were unknown. The effect of this is the final speed calculated in the second method is larger than it should have been. Overall, the sources of error suggest that the first method of calculation gave us a final speed that was smaller than it should have been, and that the second method gave us a final speed that was larger than it should have been. This helps to explain why our second method gave us a larger final speed than the first.
And finally, for a conclusion, the range of final velocities predicted by both methods overlap, meaning that they agree with each other, and this gives validity to both the velocity predicted as well as the usefulness of both methods. Neither method is perfect, as has been discussed previously, but it is obvious that despite the inaccuracy produced by not accounting for friction or air resistance, method 2 should be considered the more accurate of the two methods due to its negligible uncertainty when compared to the 13% relative uncertainty of method 1. In conclusion, the final speed of the cart was likely slightly less than 0.565 meters per second due to friction.